In the future, scientists and engineers can develop a super electric car by combining advancements in several cutting-edge technologies. Here are the key innovations that will make these cars faster, more efficient, and more powerful. Advanced battery technology, solid-state batteries. These batteries will replace lithium-ion batteries, offering faster charging, longer range, and higher safety. Graphene batteries. Lightweight and superconductive, graphene can charge in minutes and last much longer. Self-charging technology. Future cars may use solar panels, kinetic energy recovery, or wireless charging on roads. High-efficiency electric motors, ultra-lightweight motors, using materials like carbon fiber and superconductors to improve efficiency. Magnetic levitation motors. These could reduce friction and increase power output. AI-powered. Motor control. Artificial intelligence. AI can optimize power usage in real time, improving efficiency. Super-fast charging technology, wireless charging roads. Roads embedded with inductive charging coils could charge cars while driving. Ultra-fast charging stations, charging a car in under 5 minutes, just like filling a fuel tank today. AI-based charging management. Smart grids will automatically distribute power for efficient charging. Futuristic design and materials, aerodynamic shape. Cars will have a futuristic, low-drag design for higher speeds and energy efficiency. Self-healing materials. Special nanomaterials could repair small scratches or damage automatically. Ultra-lightweight composite materials. Stronger than steel but much lighter, improving speed and battery efficiency. AI and autonomous driving, self-driving cars. AI will control vehicles for maximum safety and efficiency. Predictive navigation. AI will analyze road conditions and weather to optimize performance. Voice and gesture control. Cars will respond to voice commands and gesture recognition. Next-gen connectivity and safety 5G, 6G integration. Super-fast connectivity for real-time navigation and traffic updates. Smart sensors, LiDAR, radar, and cameras for 360-degree awareness to prevent accidents. Holographic dashboards, augmented reality, AR. Dashboards will project 3D maps and real-time driving stats. Green and I. Sustainable innovations, biodegradable car parts, using eco-friendly materials to reduce waste. Hydrogen fuel cell. Backup. Some future cars may have a hydrogen fuel cell for extended range. Recyclable batteries. Advanced recycling methods will reuse battery materials, making electric cars more sustainable. Quantum computing for car performance, quantum AI optimization. Quantum computers will enhance route planning, battery management, and motor efficiency. Ultra-secure communication. Quantum encryption will prevent hacking of self-driving systems. The future of super electric cars. A detailed vision. In the coming decades, scientists and engineers will develop super electric cars that are faster, more efficient, self-sustaining, and environmentally friendly. These cars will combine cutting-edge advancements in battery technology, electric motors, artificial intelligence, connectivity, and materials science. Below is a detailed breakdown of the futuristic technologies that will power the next generation of electric vehicles, EVs. Revolutionary battery technology. One of the most crucial components of electric cars is the battery system, which directly affects range, charging speed, and overall performance. Future super-electric cars will use A. Solid-state batteries. Unlike current lithium-ion batteries, solid-state batteries use a solid electrolyte instead of a liquid one. Advantages: higher energy density, more power in a smaller size, faster charging. Times: up to 80% charge in 5-10 minutes. Safer, lower risk of overheating and explosions. Longer lifespan, lasts up to 1 million miles. B. Graphene-based batteries. Graphene is a superconductive, ultra-lightweight material that allows for ultra-fast charging. Advantages: can charge a car in less than 60 seconds. Longer durability than lithium-ion batteries. Extremely lightweight, improving overall vehicle efficiency. C. Self-charging and energy. Harvesting batteries. Future electric cars will generate power while driving through solar panels integrated into the car's body. Kinetic Energy Recovery Systems, KERS, to capture energy from braking and wheel movement. Wireless charging roads, allowing cars to charge while moving. Ultra-advanced electric motors and powertrain. Electric motors in future cars will be smaller, more powerful, and highly efficient, leading to A. Superconducting motors using high-temperature superconductors. These motors can generate more power while reducing energy loss. Key features: zero electrical resistance, improving efficiency. Compact size, allowing for more space inside the car. B. Magnetic levitation, maglev, drive system. Inspired by high speed, maglev trains future electric cars may use magnetic levitation for frictionless movement. This would eliminate mechanical wear and increase efficiency. C. AI-powered power distribution, artificial intelligence, AI, will automatically optimize power delivery, ensuring the best balance between speed, efficiency, and battery life. Super-fast charging technology. One of the biggest challenges for electric vehicles is charging time. Future super electric cars will introduce A. Ultra-fast charging stations. Next-gen charging stations will fully charge a car in under 5 minutes using megawatt-level chargers. B. Wireless inductive charging roads and parking spaces will have built-in wireless charging coils, enabling charging without plugging in. C. Smart AI-based charging management AI systems will analyze battery conditions and schedule optimal charging times to prevent overheating and battery degradation. Futuristic car design and smart materials. The physical structure of super-electric cars will undergo massive changes with lightweight, high-strength materials. A. Self-healing materials. Cars will use nano coatings and polymers that repair small scratches and dents automatically. B. Ultra-lightweight carbon fiber and aerogel carbon fiber and aerogels will make cars lighter than ever, improving efficiency and increasing speed. C. Shape-shifting bodies, morphing aerodynamics. Cars will have adaptive body panels that change shape based on speed and wind resistance, maximizing efficiency. Artificial intelligence and autonomous driving AI will make future cars smarter, safer, and fully autonomous. A. Fully autonomous driving, Level 5 automation. Cars will drive themselves using AI, LiDAR, radar, and cameras to make real-time decisions. Features include zero accidents using AI-driven safety mechanisms, smart traffic coordination to reduce congestion, automatic valet parking. Cars will park themselves. B. Predictive navigation and traffic. Control AI will analyze traffic and weather conditions to choose the best routes dynamically. C. Gesture and voice control. Drivers and passengers can control car functions using hand gestures and voice commands. Next-gen connectivity and security. Future super-electric cars will be fully connected with the internet and other vehicles. A. 6G and quantum communication. Cars will communicate with each other and smart city infrastructure in real time. This will allow for safer and more efficient driving. B. Ultra-secure quantum encryption. Quantum cryptography will prevent hacking of self-driving cars,